To design the EEG or ECG, so basically whatever measuring, EMG, it applies to all of them. So first we start with a patient, which we are gonna put a electrode. And this electrode should be, since we're measuring, it needs to be perfectly non-polarizable, which is silver chloride, so AgAgCl, and we need three of them, 3 electrode, for 2 for measuring and 1 for the driven right leg system. And then we may put it in different places rather than right leg, depends on what we are measuring. And then we're going to use coaxial cable because we want to minimize the effect of electromagnetics. Actually, no, not electromagnetic, but for electric field noise. So 60 hertz is to prevent the 60 hertz noise. Is those picture of something like that. So we have this capacitive effect going on with us. So we want to prevent that for patients and for the just cable itself, from the cable. So not only for patient but for cables. And then we're gonna put it through the difference amplifier, because they will have the common noise from these 2 electrodes. So we want to get rid of that, and we want to only amplify the difference, which is what we are interested in. And for this diff amp, we should have high CMRR, and it removes common noise. Such as 60 hertz noise, like the muscles, other muscles, if you're measuring other than EMG, or it could be like a heartbeat. And then we're going to put it through the high pass filter, and this is to remove the DC voltage, because in between electrode we're going to have some DC going on at the beginning, at least. We want to get rid of that, and we're going to put this the corner frequency really low, like something like for example, it could be like 0.01 hertz, because we're trying to remove the frequency, the DC voltage, and we don't want to go much higher, because what we are measuring is also usually goes from DC to like 50 for blood pressures, and like if it's EMG, it goes up to I think like 250 or something hertz, and it all of them like goes from like DC to 250. So we want to get rid of just the DC, like the DC, and then not too much of the lower part. And this is so this DC comes from electrode polarization. After that, we're gonna put it through the low pass filter, and it depends so we're cutting off the higher frequency, cutting off the higher frequency stuff that we don't want. So if it's EMG, I think it goes up to 250 hertz, and we don't want, if some signal is like 4,000 hertz, it's probably not signal from EMG, so we don't want that. So for corner frequency, if it's for EMG, it's gonna be 250 hertz. If it's something else, we're gonna adjust it accordingly to the table 1.1. And that is the general block diagram of whatever measuring we're doing. And for this, the circuit in general is going to look like we have this 2 op amp that is, so this is the diff amp. This is diff amp. Resistance over here, resistance over here, resistance over here. Where this is the 2 measuring site, and then we're going to put it through a high pass filter. So capacitor and resistance. So this is the high pass filter, and then we're going to put it through our low pass filter. And then we'll have V out over here. And so that's what it's gonna look like for our general circuit. This is low pass. And the details of how to calculate the desired gain we want and the corner frequency, that's pretty simple. So I'm sure you guys will get it.